Alright, welcome back to part 10, day 10, and it's about to start in 1 minute from now. So I could have started this stream a bit later, but we've got 1 minute. I'll just sip my coffee and mentally prepare. So the last one was the rope bridge one, which I thought was pretty good. And I'm not going to be rushing this. I'm still going to kind of take my time over it and explain what I'm doing, but I just thought it'd be a nice novelty to actually do it the moment the problem releases. I've done that only once already so far. So yeah, here we go. And go. Cathode-Ray tube. You avoid the ropes, plunge into the river and swim to shore. So all that effort and we still fell into the river. Wonderful. The elves yell something about meeting back up with them upriver. But the river is too loud to tell exactly what they're saying. They finish crossing the bridge and disappear from view. Situations like this must be why the elves prioritized getting the communication system on your handheld device working. You pull it out of your pack, but the amount of water slowly draining from a big crack in its screen tells you it probably won't be much of immediate use. Well, don't turn it on until you've dried it out. Unless, that is, you can design a replacement for the device's video system. It seems to be some kind of cathode-ray tube, screen, and simple CPU that are both driven by a precise clock circuit. The clock circuit ticks at a constant rate. Each tick is called a cycle. Cool. Start by figuring out the signal being sent by the CPU. The CPU has a single register, X, which starts with the value 1. It supports only 2 instructions. Add XV takes 2 cycles to complete. After 2 cycles, the X register is increased by the value V. And Noop takes 1 cycle and it does nothing. Interesting. Consider the following small program. Noop, add x3, add x minus 5. So you should end up with minus... Wait, so x starts at 1. Okay, so it should be minus 1. Okay. Maybe you can learn something by looking at the value of the X register throughout execution. For now, consider the signal strength excuse me, cycle number multiplied by the value of the X register during the 20th cycle and every 40 cycles after that. Okay, for example, consider this larger program. During the 20th cycle, okay. Alright then. Let's begin then. So we want to so we could do either 1 or 2 cycles for each command. So we might skip 20, but we can right, whatever. So let's just set x equals 1. Okay. And now cycle. What cycle do we start? So we start with cycle 1 being the first. During. Okay, so the first. We start. This is confusing. Okay, cycle 1. We begin with cycle 1. It updates to cycle 2 after one cycle has completed, I guess. Okay. Oh, I forgot to turn my... Hang on. Put my noise filter on, because there's some horrible noise coming through the mic. That looks much better. Alright, so... as before, we want to take the input... So there's just two things. If it's noob, if line starts with noob, or just damn it. Okay. If line.strip equals noob, we just add one to the cycle, else amount equals int of line.split the last element of that. So we would do x plus equal amount and cycle plus equal 2. So that does everything. We just want to catch what happens at cycle 20 and 20 plus 40k, or any value of k. So the one thing we got to be careful of is if we are at 19 and we add 2 cycles, because this is kind of an atomic operation here, we would roll over to 21. So basically we need to check if but we want what the old value of x was, not the new one. Let me just read these again. So only at the end of a cycle does x update. So we want during. So in other words, we don't actually, just before we perform the operation, if x percent 40 equals 20, or so if it's no. If it's 19 or say this. If it's in 18 or 19. So that's saying if we're at 18 or 19, This is really confusing the way they've done this. The first cycle... I see, okay. Alright, so let's just look at the two different cases. If it's a no noob, then if we are on 19 right now, we are performing the 20th cycle, and we'll end up on cycle 20. Yes, that's how they've started. So we want if... Wait, if x is 19, in that case, we will contribute to the total. Hey, it's what? Okay, total equals 0. How do we do this? So we want cycle number multiplied by the value of the X register. So we want we update the cycle, and then we do total plus equal cycle multiplied by X. So it'll be 20, for the first case it'll be 20 multiplied by X. Okay, fine. The other case is if, okay, cycle plus equal 2. That's not, we're not checking X here, we're checking cycle. And actually, at that point, it should be 20. We end up 20 doing the 20th cycle. Okay, so the other case is we are updating X. We leave up the update till the end because we want to see what X was before. We do cycle plus equal 2. Now, if we've just rolled into 20 or 21, so if cycle sent 40 in 2021, that means we've come from 18 or 19. Then again, we add Alright, you know what, let's just do this like this. Add 1. If it's 20, do that. And then just repeat this. That's just easier, and it's actually more readable. Add 1 again, if it's 20. Do that. So it'll happen one or the other. Whenever. And then we add the X. And then finally, print total. Alright, that took me way longer than it should have. 12980. This cycle business is confusing me, whether we start at 1 or 0. Yeah, we start at 1. No. No, we actually start at 0. I believe. Because we're going into the first cycle, so we want to end up on 1. Yeah. Okay, we start at 0. Yeah, that's correct. Okay, good. That was confusing. Ooh, what is this? Yikes. We've got pixel art. Everyone loves pixel art challenges. Right. It seems like the X register controls the horizontal position of a sprite. Specifically, the sprite is 3 pixels wide, and the X register sets the horizontal position of the middle of that sprite. Mm-hmm. 3 pixels wide. Okay, fine. You count the pixels on the CRT, 40 wide and 6 high. The CRT screen draws the top row of pixels from left to right, and the row below that, and so on. The CRT is tied closely to the clock circuit. The CRT draws a single pixel during each cycle, representing each pixel of the screen as a hash symbol. Huh? So now it's not... What is this diagram telling us? I don't understand. So before we had 20, 60, and so on. But now they've just... we actually have to interpret the final picture visually. Okay, cool. So why have they picked 40, 80, 120 here? Is that just arbitrary? Carefully timing. What is this? Racing the beam. Oh, I guess they're basing this problem on a real life programming challenge. Alright, we'll watch this. No, I will personally watch this another time. Carefully timing the CPU instructions and the CRT drawing operations, you should be able to determine whether the sprite is visible the instant each pixel is drawn. If the sprite is positioned such that one of its 3 pixels is the pixel currently being drawn, the screen produces a lit pixel. Otherwise, the screen leaves the pixel dark. I'm still a bit lost. Why? I don't understand what 40, 80, 120 have got to do with it. Are they just picking arbitrary numbers here just for this diagram? Maybe this diagram is not helpful. Right, so... Alright, so the CRT draws a single... Okay, each cycle from 1, 2, 3, so on. Oh, I see. I know what this diagram is telling us now. It's just saying that this width is 40, so at 41 it moves to the next one. Oh, fine. Okay, that makes sense. Okay. If the sprite is positioned such that one of its 3 pixels is the pixel currently being drawn, otherwise it leaves it dark. Okay. So okay. I'm not even going to read the example. I'm going to try this. Just try it. Alright, so we just go step by step. And we check if the pixel being drawn at this point in time, because we know what the XY coordinates of it are, fall in the sprite's range, which is like 3 pixels wide for each cycle. So okay, I have enough to go on. Okay, that was hard to get my head around. Okay, so we need a grid. Grid equals... So by default, it's dot times 40 times 6, so it's 40 dots. Oh, we don't want to change. So make this a list. So we want... Okay, just print grid. I want to see if I've got this right. So the first row will just be dots, and then we've got 6 of those. Yeah, that's correct. So grid looks like that, and that gives us the ability to change any to a hash. So each time we move to a new cycle, basically every time we do cycle plus equal 1. So we don't care about this total. We can continue computing it just so that this is backwards compatible. Cycle plus equal 1, so it's during the cycle, so the X value hasn't updated yet. Right, so it's at this moment right here that we... Hang on. Yeah, that's right. This moment right here that we want to say... if... X... The pixel being drawn, we need to know the X and Y values. So X... We've got multiple X's here. Let's just say I equals cycle. Hang on. Before we update cycle, I equals cycle divided by 40. J equals cycle modulus 40. So that gives us the row and the column. If, so the J is the key factor. If J is less than, so we want to compare it with sprite, the x value of sprite, because that is telling us the horizontal position. So if J but it's sandwiched, so we want a deviation of one each side, because it could be that the middle is a bit to the right or a bit to the left, in which case it'll still get drawn. If sprite, no, not sprite, x, then we draw it. So grid I j equals hash. So let's try that. Also, let's make this a bit, we want to see what it looks like visually. So for row in grid, print the join of that row. So that will just make it joined up. Okay, so that's what it looks like right now. If we're just using the no noops. Can we work out what characters those are? Not yet. Okay, so now we do the same down here. It's exactly the same code, is it not? If before we do cycle plus equal 1, we do that. And then we just do it again down here. Do we just, is that it? No, that doesn't look right. That's way too symmetrical. Why is that happening? Oh. I think it's because I've done that thing that happens with lists. Hang on. Dot times 40. In range 6. I think they're all under the same pointer. It's a weird thing that I've made that mistake since the beginning, my beginning days of Python. There we go. So yeah, you can't just duplicate lists like that, because then they all come under the same pointer. And if you change one, you change more. The best way to alleviate that is to generate your lists using an explicit generator. That way they all fall under different pointers and won't be changed. So what have we got here? P. So this P. Kind of have to squint. P. Z G R A Z A. Maybe if we were to do space, it would actually be clearer. Oh, that is much clearer. PBZGRAZA. I mean, that has got to be the right answer. It can't possibly be that we've generated a different set of letters. So that makes me confident. Nice. All right. that is day 10. I did that in half an hour. Reasonable, I guess. I wasn't really rushing. It took me a long time to understand the natural language description of that. After that, it's not too bad. Also, the cycle thing is confusing because it wasn't clear whether you're starting on 0 or 1. You got to think of cycle being a movement from one point to another in the timeline. It is a good problem, and also having to interpret the result as a visual thing, that's quite cool actually. So yeah, I've caught up because I had to do 2 problems today to catch up again. So tomorrow we're back with day 11. 20 stars so far. So in that case, part 2 was significantly harder than part 1, which is what I like. In some cases, part 2 was actually easier or just roughly equivalent. It's just changing something. In this case, you had to actually rethink how to build and what you did before. That's what I prefer. I think everyone prefers that, surely. So, yep. See you tomorrow.